Hi, and welcome to our video, everyone. Today, we will explore about the problem of concurrency control, but more specifically to scheduler.
Have you ever wondered what happens if two people access the same data at the same time? In database system, when many transactions occur simultaneously, serious problem can occur if not controlled.
Wait, so what is scheduler? Actually, the scheduler is a special DBMS process that manages how multiple transactions are executed to prevent conflicts and maintain data consistency. It also controls the order of database operations are performed, allowing only one update at a time to avoid temporary inconsistencies. So, what kind of analogy that give off the same vibe to this explanation? Imagine there's a narrow one-lane road that only allows one car to pass at a time. Both cars were about to use the same road, so the two vehicles are traveled simultaneously because there are no traffic lights there. Happened just like data is being crashed. So now let's take a look at a situation that has a scheduler. Scheduler in this situation is a traffic light, while the car is a transaction. T1 will go first according to the traffic light sequence, and now followed by T2. Because of the traffic lights, no violations occurred and traffic flowed smoothly.
To better understand, let's look at the next analogy. There's one teacher and two of her students were doing a coloring session on the same picture at the same time. Then something unexpected happened. The colored pencil mixed and the picture became blurry.
Two people take turns. One color first, then the other continues to color it.
The two students then colored one by one calmly without disturbing the work of others.
Yay! Done!
Now let's look at the next part, which is the role of the scheduler. So the first role of the scheduler is to prevent conflicts from occurring. The scheduler can avoid overlap in read or write operations. The next role is to ensure serializability, which can control the order of operations. Is the same as if the transactions were executed one after the other. Not only that, the scheduler can maintain an isolation for ensures that a transaction runs as if it's the only one in the system. Next, we move on to the other part. All right now, for the type of scheduler.
Firstly, the transaction. It's responsible for determining the order in which transactions are executed.
Second, the query. It's responsible for managing and optimizing the execution of individual queries or sets of queries.
Thirdly, these serial schedules. All the transactions are executed serially one after the other. It means a transaction does not start execution until the currently running transaction finishes execution.
Next, the non-serial schedules. Multiple transactions execute simultaneously. Unlike the serial schedules, the other transaction proceeds without the completion of the previous transaction.
Next, we move on to how schedulers solve the problem. Schedulers solve the problem by using two-phase locking concept. What is two-phase locking? It is a protocol used to ensure serializability in concurrent database transaction. It ensures that the final result of concurrent transactions is the same as if they were executed one after another. Two-phase locking have two phases. First one is growing phase, and the second phase, shrinking phase. Let's discover the growing phase first. Growing phase. Transaction can acquire locks, but it cannot release any lock. The transaction also can keep requesting all the locks it needs. For example, based on the picture above, transaction T1 requests lock XA and lock SB. As long as it hasn't released any lock yet, it's in the growing phase.
Next, the shrinking phase. Once the transaction releases a lock, it cannot request any new lock. However, it can only release the remaining locks. This rule prevents back and forth locking and unlocking.
Let's look at another point, which is deadlock detection and resolution. But what is the deadlock? Deadlock happens when two or more transactions are waiting for each other's resources and none of them can proceed.
Timestamp ordering, concurrency control method that ensures transactions are executed in the order of their timestamps. First comes, first serves. Advantages: no need for locking, avoids deadlocks, easy to understand and follow. Disadvantages: cause many rollbacks, performance can drop in high concurrency systems.
Next is optimistic concurrency control. Did you know what is optimistic concurrency control? Well, it's a method of managing transactions without locking. It assumes that conflicts between transactions are rare. There are 3 phases of optimistic concurrency control, which is read phase, verify phase, and write phase.
For the read phase, transaction reads data and performs the operation in a private workspace. For example, happens without actually reserving the item yet. You view the product page, then you add size 38 to your cart, and then you calculate total price with discount.
Next, the validation phase. The transactions checks if any other transaction changed the data it used before committing. For example, double-checking if no one changed the price before confirming your online order.
Lastly, the write phase. If validation passes, the transaction writes updates to the actual database. For example, you click Place Order. System checks if the product is still in stock. If still available, your order is confirmed. If someone else bought them first, order fails, you have to start again.
In conclusion, the scheduler helps ensure system resources, like CPU and storage, are used efficiently by managing transactions in an orderly way, often using a first-come, first-serve approach.